All right, for part 2 of our video, we are now talking about area. Remember that area is different than perimeter. Perimeter is a unit of length, a straight line. Area is the amount of space an object covers. When we talk about area, we are talking about square units. What we are literally saying is how many squares of a specific size does it take to cover a surface? So with area, it is important that we deal with square units, which is why all of these right angles are super important, because you cannot form a square without right angles. So when dealing with area, you've got to deal with square dimensions. So the first object we have is a square. Nice thing about a square is all of the side lengths are the same. So let's just say that this is 3 millimeters by 3 millimeters. To find area, you multiply perpendicular dimensions, which means dimensions that are set at right angles. So to find the area of a square, we would take the side times the side, because both sides are the same. And when you multiply something by itself, you are squaring that thing, which is where we get area of a square equals s squared. So if we plug in our dimensions, we could take 3 millimeters and square it or multiply it by itself. 3 times 3 gives us 9. Millimeters times millimeters. Remember, when you multiply units by themselves, you get a square unit. So we'd get 9 millimeters squared. So the formula for the area of a square is s squared. We see that in action here. So now let's move on to a rectangle. In a rectangle, you have the length and the width. The nice thing about a rectangle is the dimensions are perpendicular, meaning they already meet at a right angle, meaning that we're already dealing with square units. So let's call this 5. Let's call this 2. So to find the area of a rectangle, we would take the length times the width. So let's attach some units here. Let's call it inches. So to find the area of this rectangle, we'd take length times width, which would be 5 inches times 2 inches. 5 times 2 gives us 10. Inches times inches gives us square inches. Remember, we use that exponent 2 to show square inches, to show something multiplied by itself. All right, our next shape is a parallelogram, and it is a parallelogram that is not a square or a rectangle. So, weird thing about a parallelogram is we can have the length and the width, which we use for perimeter, but because these do not meet at a right angle, we need to rename them. So we always call the bottom side the base, and then because for area we need right angles, we actually sometimes have an imaginary line that intersects our base at, again, all important, right angle, called the height. So let's call our base 10 centimeters and our height 4 centimeters. To find area, we multiply perpendicular dimensions. In a parallelogram, our perpendicular dimensions are our base and our height. So the area of a parallelogram is base times height. So for this particular parallelogram, we'd take our base, which is 10 centimeters, times our height, which is 4 centimeters. So we'd get 10 times 4, which gives us 40 centimeters times centimeters, which again, with area, gives us square units. So we'd have 40 centimeters squared. So that's a parallelogram. Lastly, we're going to talk about a triangle. So in a triangle, The only time that you have perpendicular dimensions, in which your dimensions are the side lengths of your triangle, is a right triangle, where the bottom of your triangle and the side of your triangle meet at a 90-degree angle. With other types of triangles, that is not the case. So here I've got a base, but neither of the sides meet the base at a right angle. Same idea here. We've got our base, but neither one of the other sides meets our base at a right angle. So just like with our parallelogram, with certain triangles, we actually have to have an imaginary line called the height, because it is the height that meets our base at a right angle. So for a triangle, we've got a base and a height. A base, and in this case, the imaginary line is our height. Again, a base, and this one's a little funky because the height actually appears outside of our triangle, because that's what it takes to get this right angle. Area needs square units, we need right angles. So in this case, we actually have an imaginary line called the height outside of our triangle. Now, for any triangle, the area of a triangle is the base times the height. But remember up here, when we took the base times the height, we actually got a parallelogram. If I were to simply take the base times the height for this triangle, what I would get is a parallelogram. Same idea here, base times height, I would get a parallelogram. Base times height, another parallelogram. So what we have to do is we actually have to take our base times our height and then divide it by 2, because this triangle is half of the parallelogram that it comes from. So for the area of a triangle, we've got to take our base times our height and divide it by 2. Now there are actually 2 formulas for the area of a triangle, because dividing by 2 is the same thing as multiplying by its reciprocal. We actually can take 1/2 the base times the height. Both will give us the same result. So let's just work through an example real quick. Let's use this super funky one over here. Let's call our base 10, and let's call our height 6. So plugging into this formula, area equals base times height. Base is 10, height is 6, divided by 2. So we get 10 times 6 is 60, divided by 2 gives us 30. I didn't apply units, so 30 units squared. Now, let's try our second formula and see if it gives us the same result. So we just used this one right here. Let's try this one over here. So area equals 1/2. Our base is 10, and our height is 6. So we can take 1/2 of 10, which gives us 5, times our height, which is 6. 5 times 6 gives us 30. Again, we don't know what the units are, so we know it's area, so we need units squared. And there are your formulas for the area of our geometric shapes.